Okay, and now I'm going to hit. Does anybody else have any announcements? Share screen and see if I can. There we go. Now we'll try to put it on slideshow.
Am I showing? Whoops. I am showing a little. Ooh.
Yeah, we're showing just a little bit of it. Let's see. I'm looking for the slideshow. I don't.
Okay,
Ah,
well,
start from beginning. There we go. That's
there.
a little bit better. There we go. Okay, well, today we're going to talk about water, specifically water relative to Colorado. And in this opening intro slide, we have a picture of the Morro Point Dam. There are two dams in central Colorado, pretty close to one another, within 15 miles of each other, both on the Gunnison River. And there's one upstream called the Blue Mesa Dam, and then downstream of it, the Morro Point Dam. And when I am no more, I want my ashes scattered just below Morro Point Dam, where the Cimarron River joins the Gunnison. But we drove past the Blue Mesa Reservoir just 3 or 4 weeks ago, and they're dropping it at a rate of over 2 feet per week. So this is a picture recently showing a lot of the area of the lake that's come down and you don't see anymore.
Oh my.
Yeah, couple good references if you want to read more. A good almost 20 years ago, there was I think about a 6-part special on TV called Cadillac Desert. It was based on the book by Mark Reisner with the same name called Cadillac Desert, subtitled The American West and Its Disappearing Water. And there's a book that's just come out that's kind of a follow-on to Cadillac Desert called Downriver, Future of the West. So both those books are highly recommended.
It's open like that. Gee, that looks.
Just out of curiosity, how many in the class or how many on, at least on today, does anybody get their water from what I call a private well? Guess not. I guess most of us get either the standard Douglas County source or Denver water or whatever. Okay. We'll use the terms today, groundwater and surface water. Water doesn't mean rivers. It means literally water that is underground. And then surface water is the water visible from somebody standing uh, on the surface. And of course, you can have groundwater that is adding to stream flow. In other words, water seeping from springs and the ground into a creek and feeding it. Or you can have the reverse, where the surface water in a creek is dispersing into the ground. Of course, it depends on where the water table stands, uh, determine which of those is happening. Okay, a quick map of the United States. Uh, there's an old saying, if you're trying to farm, don't go west of the 100th meridian. The meridian lines, of course, go from north to south across the earth. And you can't see the state borders very well, but in general, you can see the annual rainfall occurring in various areas of the state. The blues and the darker blues are areas where you have higher rainfall, and the tans are colors where the rainfall is very sparse. You can see as you're driving across, for those who have driven to Kansas City or even over to St. Louis, you know, as you drive out of St. Louis, you keep going, you get to Kansas City, and you head across Kansas, the amount of rainfall just keeps decreasing as you head westward. And by the time you get into substantial western Kansas, the amount of rain is down to 10 to 20 inches a year. And that means if you're trying to farm in western Kansas, you're probably going to need irrigation help for almost any crop. Uh, and then as you go further west, things get even drier, and particularly in the southwest. And we know the rainfall projections are worsening with climate change. Denver is in a rainfall category of roughly 14, 15 inches a year of rainfall, compared to a place like, say, Cincinnati, Ohio, it gets closer to 40 inches of rain. Uh, and the rivers show it. This upper drawing here shows proportionally uh, the size of rivers in terms of volumetric flow. How much, how many cubic feet per second are actually going down the rivers? And it doesn't take a genius to figure out that 100th meridian line is a true observation. The water in the United States is predominantly there in the east and also in the Pacific Northwest with the mighty Columbia and Snake River. And the Southwest United States is a difficult place for crops and water. And unfortunately, the uh, climate change is impacting the Southwest more so. So it's going from bad to worse for the Southwest United States.
Arizona's getting rain.
Yeah. Uh, this next slide shows the volumetric flow of rivers. And of course, the biggest one in the United States in terms of cubic feet per second is the Mississippi down there at New Orleans. The relatively close second is the St. Lawrence River, then the Ohio, the Columbia, the Yukon, the Missouri, and the Tennessee. But we see the bar graph decreasing pretty quickly. Uh, Interesting observation, where the Ohio River joins the Mississippi River, the Ohio actually has the greater flow. Uh, so if they named rivers according to a smaller flow rate joining the larger one, they would call the Mississippi River the Ohio River. Uh, the poor South Platte is a very tiny river. It doesn't even show up on this graph. If we march down uh, several hundred bars lower, we'd finally find the South Platte, and it's only got 300, roughly 340 cubic feet per second average. Compared to the Ohio River, it only has 1,000th or 2,000ths of what's flowing in the Ohio River. Or to compare the South Platte to the Susquehanna, it's only got 100th of or less of what's in the Susquehanna. So the South Platte is truly, by Eastern standards, kind of a creek. There's some of the flow rates. Again, the South Platte is 340 cubic feet per second. And we can see some of these creeks and small flows in Colorado, and they're truly pretty small. Notice Boulder Creek is 58 cubic feet per second down there at the bottom. And even the Big Thompson River is only 44 cubic feet per second on the average. That's only 1/10 of what's in the South Platte. So river-wise, we've got some pretty small surface water rivers. Okay, let's look at Colorado and where the rain falls. On this map, the more purple you are, the more blue you are, the more rain you get, and the redder and tanner you are, the less rainfall you see. And as we can see, Denver is in the 14 to 16 inches precipitation per year range. Interestingly enough, as you drive down I-25, just past, and you get closer to Monument, you go past an area called, is it Greenland?
Yes.
Yeah, and that's an area where there's actually some moisture coming through the mountains, and that gets several more inches of rain per year. So if you buy a farm in Colorado, you got to pay very careful attention to where you are on the map. And you can make relatively small geographic movements in Colorado and get to areas of dramatically less or significantly more rainfall. So that's our state. Okay, Western United States. It's a fact. 78% of Western water is used for agriculture. And in Arizona, 87% of the consumed water goes to irrigation. So Arizona ranks the highest with about 87% going to agricultural irrigation. Colorado, New Mexico are a close second. So there's the usage. In Colorado, 86.5% is used for agriculture. A little less than 7% for the municipalities, 3% for recreation, fisheries, stream flows, and very small amounts for other uses. So agriculture is the big dominator, the big user of water. For those of you who have gone out to the western area of the state near Montrose, you've probably seen the Olathe sweet corn ads, and they're trying to come up with innovative ways to cut back the amount of water used in Colorado by agriculture. An area down near Crowley. Crowley is maybe, 45 minutes eastward out of Pueblo. They've just about sold all the farming water rights to cities such as Aurora and kind of shut down agriculture in some parts of Colorado, especially around Crowley. So that trend is continuing, and it's probably going to continue for the future. There's probably going to be less and less agriculture and more pressure on farmers to sell their water rights and get out of farming, just the way it's happening. Okay, Colorado is a source state. There are essentially no rivers or streams flowing into Colorado from elsewhere. We're the quote high ground. We're an outflow state, and more than virtually, all of our streams leave the state and don't enter the state. This graph shows the by width of the streams, the relative amounts of water carried by them. And as you can see, almost all the water leaving the state is going out on the western side. A little bit going out on the South Platte and the Arkansas. These measurements, by the way, are in the units of acre feet. An acre foot is the amount of water it would take to take 1 acre of land and immerse it in 1 foot of water. But you can see where the Colorado River is the big driver and gets most of its source right there from the good old state of Colorado. But notice these two subgraphs on the chart, the east slope and the west slope, and look at the population. The east slope has the people, well over 4.5 million. This chart's a little bit out of date. It's closer to 5.5 million now. And the west slope is not even 1 million people yet. And the amount of irrigated acres on the eastern side is more than 2.5 times what we have on the western side. So the people and the agriculture is more on the eastern side of Colorado, and the water flow is on the western side. Here's that chart again. That shows a lot of the substreams. And you can see where the South Platte and the Arkansas get sucked down. The farms up there in the northeast Colorado draw a lot of water from the South Platte, and likewise for the Arkansas. And I'm quite sure the state of, I think both Nebraska and Kansas have sued Colorado to assure we don't take too much water from the South Platte and the Arkansas, and that we allow sufficient quantities to get to them, because we could literally suck those two rivers dry if we didn't have water rules.
Ron, are some of your charts going to show the water that is being brought over the hill?
Yeah,
From-
we're gonna show the big three from Denver Water.
Thank you.
Okay, this next chart shows the evaporation rate in Colorado, and we can say, well, gee, doesn't more water evaporate from the high altitude areas because of the low pressure? And that has a minor effect, but it's really temperature that's the big driver in evaporation of water. So we can see down there by Lamar and Pueblo, those purple regions, you get a lot more inches per year evaporate off of reservoirs and dams and lakes. And you get substantially less evaporate off of high altitude lakes. That tells you if you're going to build a water storage system, ideally, to cut down the evaporation loss, you want to put it in a cooler area. And that usually means higher altitude areas. Okay. And answering the question, where does Denver Water get its supplies from? Obviously, it's crucial in Colorado to store water. Unlike Ohio, you can't just walk down to the big Ohio River and draw up all the water you want any time of year. Here in Colorado, we've got to store water and store it by the millions of gallons or whatever. So these are the largest reservoirs in Colorado, and we can see, at least for Denver Water, this is the Denver Water ones. Lake Dillon is the big boy. About 37% of the storage capability for Denver Water is Lake Dillon. And then the other two that you hear about, but hardly anybody's seen or gone to, are 11 Mile Canyon and Williams Fork. We'll show those on a map in a moment. But those are, in fact, those big three are all on the other side of the Continental Divide. But we can see those first three or four are the big boys. The vast majority of Denver Water storage is in just those first four dams. So we definitely rely on the big boys, as I call them, the vast majority of our water storage capability. Okay, and so here's a map showing where some of those reservoirs are. And notice the Williams Fork Reservoir is definitely on the other side of the divide. If you start in Winter Park and start traveling westward, you'll eventually get to Williams Fork. Virtually nobody goes out there. I've never seen it with my eyes. Of course, we all drive past the Dillon Reservoir as we travel out I-70. But another one nobody hardly knows about is the 11 Mile Reservoir. If you went out Highway 285 and then headed dramatically south from there, and you get to that 11 Mile Reservoir. The 11 Mile Reservoir is actually closer to Colorado Springs than it is to Denver. Then there's the Antero Reservoir, and there's, of course, the Roberts Tunnel, which you might see as you go through Grant, driving out 285. But our big water storages for Denver are all on the other side of the Continental Divide. And I'll have to check on Cheeseman Reservoir. I'll have to see what side of the divide that's on. But again, the majority of our water storage is on the other side of the Continental Divide. Okay, this is an unreadable chart, but I'll jump over it real quickly. Of course, you want to also not only pay attention to how much water you have, but certainly for drinking and recreation, you want clean water. And at least there we catch a break. Colorado has some of the cleanest water in the country. We've got some contamination, but generally the Denver water supply rates extremely good. And some of the bad things you don't want in your water are things like arsenic, beryllium, chromium, certainly mercury and strontium. Um, and if you look at a water quality chart, uh, BRL means below registered level. That means the level they measure of it is so low that it doesn't even measure on the instruments. Uh, MCL stands for maximum contaminant level in parts per million, or is it parts? Yeah, I think it's parts per million. And that's the maximum contaminant level. And then the second column, or this one I'm pointing to, is the maximum contaminant level goal. So we're lucky that we don't have violations in Colorado, or at least in Denver. Uh, there's a picture of water treatment plants. And of course, when you design a water treatment plant, for economy purposes, you got to have a pretty good idea when you design of what your water source is. If you've got a water source that's got heavy metals in it or got some other contaminant, uh, you've got to actually alter the design of the plant to take into account what you've got. Maybe you've got massive amounts of E. coli, bad stuff. You got to temper the design of the plant to handle your sources. And we're fortunate again for Denver water. They have some pretty darn good basins. Those basins are, of course, have been affected by the fires, but the kind of things the fires tend to be putting in the water are not the real bad boys. They're not the heavy metals. It's more some of the organic compounds from the burn washout. Uh, well, after just saying what wonderful water we have in Colorado, at the same time, we can't claim the whole state has pristine water. Uh, this is a map that shows some of the contaminated water streams we have in Colorado. And you say, well, where did the contamination come from? And almost unequivocally, you can say it's been hard rock mining. It's screwed up some streams badly in Colorado. This picture here shows, whoops, the Uncompahgre River, and it's orange. For those of you that have driven the $1 Million Highway between Ouray and Silverton, you've probably noticed the orange stream and orange streams in a few other areas of the state, some of which are badly contaminated with particularly the heavy metals and the acid mine drainage. So hard rock mining has taken a toll on Colorado water. We're just fortunate in the Denver area to have watersheds that are isolated from that mining. All right. Yeah, any questions? All right. This is a map that shows the eastern border of Colorado with Kansas, Nebraska, Oklahoma, and Texas. And this is one of the most famous water aquifers in the world. An aquifer, of course, is an underground geologic storage place for water. And the famous Ogallala aquifer is one of the biggest aquifers in the world, but it's unfortunately also one of the ones that's dropping in level the fastest. There's a quote from a water engineer in New Mexico. He said, "We made a conscious decision to mine out our share of the Ogallala in a period of 25 to 40 years." And some farmers are taking 5 feet a year out of the Ogallala aquifer, while nature puts back, they estimate, perhaps 1/4 of an inch. So it's like a bank account that you're drawing down. And we've unfortunately got a lot of aquifers that we're dropping, and we're draining the bank accounts way faster than they can ever be recharged. All righty. The famous John Leslie Powell, when he went west, uh, he made the notes, and this was back in the late 1800s. He said in lots of areas of Utah, Wyoming, Montana, a grazing plot for homesteaders had to be 2,500 to 5,000 acres. Of course, they didn't make the homesteads that big in general. And the railroads, of course, were given 5 mile strips of land on each side of the railroad track they built as they headed west and sold that land. The property I'm speaking from today, my little suburban house lot in Centennial, Colorado, I looked at the deed, and the Union Pacific Railroad had to cede the water rights and relinquish the water rights when they sold this land to developers. So this piece of land I'm sitting on and talking from today was once Union Pacific land given to the railroad for building a railroad south of Denver. Uh, I'm not sure. At any rate, one of the bad things the railroaders did was hoodwinked settlers. They told them they put out flyers and stuff and said, "Come on out west. We'll give you some land or sell it to you at a very low price. Get yourself a train ticket. Come on out here. Be a homesteader. Get started." And they put people on land to start farms where I don't know if they knew or they should have known that the farms were doomed from the start. They put people on pieces of land where they tried to raise wheat or corn or something else, and the rainfall was so woefully deficient in massive amounts of western land that you simply could not make a go of the farm. The crop would fail 7 or 8 years out of 10. So awful lot of Western homesteaders were hoodwinked into trying to farm places where it was hopeless. Okay. We also need to talk, when we talk about grabbing river water for irrigation, uh, salinity. At the headwaters of the Arkansas River, uh, there's only a trace of salt. For those that have done some rafting in the Arkansas Valley down there near Buena Vista, and as you go upriver, up the valley of the Arkansas, the salinity, the salt contents, actually pretty low. But by the time you get downriver to what's Cannon City and whatever, the salinity is up to 2,200 parts per million. And on some rivers like the Colorado and the Platte, the same water can be used 18 times over, where it's drawn out, poured through fields for irrigation. Some of it gets back into the river, gets drawn out again, and you end up building up the salt content. There's a heavily irrigated strip of the Pecos River in New Mexico where the salinity is 720 parts per million. That's not too bad. It's not good. But just 30 miles downriver, the salinity is built up to over 2,000. Over 2,000 parts per million spells death for a lot of crops. And the Passaians Basin, and that's a basin down here in southwest Colorado. Here's a map of it. Here's the Colorado-Utah border. There's some small tributaries with natural concentrations of salt at 90,000 parts per million. And that's 3 times what almost any crop can stand. So Colorado and Wyoming do have some natural streams. They're so saline, so salty, the cattle can't drink it, people can't drink it, and you certainly can't pour it on anything. It'll kill your crops. It's like pouring containers of salt on your plants. This shows the South Platte salinity. And as it flows out of Waterton Canyon, and you can see it building up from just under 600 parts per million. As it makes its big turn, comes out of Denver, heads eastward, it's built up to 800. And you can see as it starts working its way up through the heavily irrigated areas in the eastern plains, the salt content is going up. So it's increased from its source there in Waterton Canyon of 600. It's doubled up to almost 1,300 before it gets to Nebraska, Kansas. The archaeologists have discovered in the famous Fertile Crescent, Mesopotamia. There's the land of Iran, Iraq, whatever. Doing research, they found that the early Babylonians and whatever used irrigation, and they started off with wheat around 3,500 BC, and that's a long time ago. And then they built the salinity content of the river up, the Euphrates and whatever, up. So they had to basically stop doing wheat and go to barley, and then they hundreds more years of irrigation. They ran it up so even the barley started failing. So here's an example of mankind using irrigation, but over hundreds of years building up salinity so high that it knocks out ability to raise crops. Okay. We also have the issue of reservoirs not lasting forever. This shows the volumetric capability of dams decreasing over time. You can see Hoover Dam, this isn't too bad of a degree decrease. Because of silt buildup behind Hoover Dam, the capacity of the dam decreased from 32 million acre feet to 31. That's not too bad. Coe Dam in North Carolina, talk about silt buildup. In 30 years, there was enough silt built up behind that dam in North Carolina to cut the lake capacity down to, what, 35% or less of its original. So this is a worry. Less of a worry out west. Our rivers tend to be more flowing over granitic rocks, hard rocks that doesn't have all the mud of a lot of the eastern rivers. So fortunately, a lot of our dams and reservoirs don't fill up with silt nearly as fast as a lot of the eastern rivers. Okay. We want to talk a little bit about subsidies. This actually is a picture of Arizona, and it shows the water table drop in sections of Arizona. And I can't, there we go. And we can see there are areas of Arizona where they've dropped the water table more than 150 feet. And Arizona in general is really killing its aquifers, draining them and dropping them lower and lower. Back in President Carter's term in the presidency, he questioned some of the Western water state projects that were returning 5 cents on the dollar spent. Interestingly enough, in Arizona, there's a lot of, particularly farmers down there, that have screamed about politics. You know, the government's spending too much, get the government off our backs. And yet the Arizona Salt River Project took billions of dollars of money collected from everyone in the United States and poured it into massive water projects to allow farming in Arizona. And if you picked up the Denver Post this morning, you'll notice an article that talks about an Arizona farmer that has to cut back, trying to grow corn in parts of Arizona that frankly aren't really suitable for corn. But it's amazing how people can say in some of these areas, get the government off my back, and yet take massive subsidies for water projects that put things like food stamps and other kinds of social spending uh, to shame in terms of amount of money spent. Particularly in Idaho, they've built some dams up in Idaho that benefit maybe just a few hundred farms. So there's cases up there of again ultra tax uh, hating, get the government off our back. We want freedom. Uh, People that have benefited enormously and have taken phenomenal subsidies from the government for water projects. Okay, aquifer reliance in Colorado. The bluer you are on this map, the more water you suck from the aquifers. And we can see in Colorado, there's really about 3 places that really draw on the aquifers heavily. That is the San Luis Valley, particularly around Alamosa, and then the areas up near Greeley and Weld County. They're taking quite a bit of water out of the aquifers from up there, and then down in the southeast corner of Colorado, they're drawing heavily on the aquifers. Again, this plot shows fresh groundwater withdrawals. Denver is right here. So we're in the 10,000 to 25,000. Yeah.
Ron, what are they growing in the southeast that requires such a drain?
I'm not a crop expert down there, but certainly, is that the cantaloupe area?
Yeah, Rocky Ford, melons, watermelons, cantaloupe.
Okay. And I know they're still trying to grow some other crops down that way. But the pink color is the groundwater or the aquifer water draw you're taking. And these circles are also proportional to the amount your county is drawing. For example, if we compare Arapahoe County to Weld County, we can see Weld County takes way more water than Arapahoe, largely because of heavy agriculture. I guess you could say Weld County probably is the most agriculturally productive area in the state based on its water consumption.
What about oil wells?
Let's see. That's off this map, the Palisades, but that area does draw on the aquifers a good bit. Here's a picture of center pivot irrigation circles shown on a satellite-like map of the San Luis Valley. And you can see all of the center pivot aquifer drawdown that's occurring in the San Luis Valley, and they're struggling now as the aquifer is getting lower and lower. As you have all these irrigation projects going on, sucking water out of the aquifer down there. Okay. And yeah, Alice has mentioned there's been lawsuits down there. Denver has about 4 aquifers, and I'm not going to beat in the detail on them, but the 4 aquifers we have, and remember, you can have multiple aquifers below you. If you're in the right Denver area here, you can have no less than 4 aquifers beneath you at different depths. And the big boys are the Laramie, Fox Hills, and the Arapahoe. Then there's the one named for Gene Dawson, right? Just kidding. But this shows the estimated reserves in those aquifers and the amount recoverable. You can't drain every drop out of the aquifers, but these are the estimated amounts of million acre feet in the aquifers. This shows the water quality in the aquifers. Remember, there are natural pollutants and metals and other substances in water. We can see where uh, different aquifers have dramatically different water qualities. For example, the Laramie Fox Hills is really high in bicarbonate, meaning it's alkaline, and sodium, salty. So if you're trying to dodge salt and alkalinity, the Laramie Fox Hills is the one that's the highest, whereas the Denver aquifer and the Dawson aquifer are much better in terms of water quality relative to salinity and alkalinity. You can also see the dissolved solids are much higher in the Laramie Fox Hills. Okay. Uh, the next charts, we'll blitz over them real quick so we can get to the discussion. The aquifers vary in terms of their constituent basis. Uh, some are a lot of gravel and loose sand, and that tends to have a lot of void space and be able to hold a lot of water. Other ones are sandstone, which has porosity, but not nearly as much as loose gravel. And so aquifers vary depending on what their basic material is. The Arapahoe aquifer is considered our deep rock water. It's our best water quality. Let's go back to the chart. Let's see. Arapahoe, Denver, Dawson. So they vary. And then the Laramie Fox Hills is largely sandstone. It's about 350 feet thick, and it's about 3,000 feet deep in the vicinity of Parker. So you got to dig pretty deep to get to that baby if you're down there at Parker. Wells typically yield 100 to 150 gallons per minute. Okay. Well, what are the moral perspectives? We have to consider subsidies. Who are we subsidizing? By how much? What kind of subsidies are fair? What subsidies are unjust? We have to look at the depletion of the resources for future generations. In some cases, they've elected to draw from aquifers so that they have what they consider a 100-year life. They say, we think that there's this much water in the aquifer, we'll allow a drawdown rate so it'll drain in 100 years, which sounds okay for now, but for your great-grandchildren, things are going to go dry. We know water shortages cause wars eventually can cause wars between countries. Ethiopia has put a big dam on the Nile River, and the Egyptians are very concerned about the Ethiopians filling that dam and cutting the water flow rate of the Nile back for many years to get that big Ethiopian waters dam filled with water. And so that's causing some tension between Ethiopia and Egypt. And of course, the pollution. Pollution can last for eons. Some of those contaminated rivers in Colorado will almost never recover. Once you've poured heavy amounts of heavy metals and stuff into a river, it could take multiple centuries or millennia even for the river to recover, if at all. Okay. Well, I've talked too much. Let's ask people about their perspectives on water. Had one discussion this morning about lawns. Green lawns that everybody loves, golf courses, of course, depend on, are actually considered fairly ecologically dead zones. They don't support much diversity of life in terms of different types of plants, insects, and birds. They're not sterile environments like bare sand, but they're not nearly the kind of environment of an unplowed field that's just been allowed to go fallow and naturally grow plants and stuff. So, what is the future of green lawns in Denver? Do you think we should have green lawns? There are already limits in many areas. I know one person in Aurora said in our subdivision, they allow no more than a certain percentage of your plot to be lawn, and had strict limits on new subdivisions in terms of percentage of the plot that could be put into green grass. So, what are your thoughts? What's your water quality from your source? What's your thought on green lawns? Are you willing to give up some of your green lawn? Should you?
Say,
What do you
Ron,
think, guys? What's
Ron,
that?
a
Yeah.
question. We used to have in Denver, certain days you could water your lawn. Do you have any insight as to the politics as to why that's no longer seemingly being enforced? Watering days when you could water your lawn. Do you have any why that was discontinued?
I know Denver Water sends out rules, but you're right. I don't think the enforcement is much at all. It's largely it's hard to enforce. How do you find out who's watering your lawn 3 times a day in the middle of the day?
I wonder if something along the lines of cap and trade could apply to water usage. Because when you think about these giant golf courses and, high users, I mean, obviously the market can control a lot of this, but the cap and trade, which we've deployed, might be an interesting application.
In essence, we already have that in terms of the Colorado water law. We could certainly do a whole month's worth of lessons on water law. Certain people have water rights, and it's usually the first person there would maybe put an apple orchard next to the Colorado River, draw off a certain amount of water in maybe the year 1880, and they were there firstest with the mostest, and have water rights that date back more than a century. Someone told me of the Comanche power plant in Colorado having water rights. They're some of the earliest, and water law is very difficult, and to a certain extent, it's very unfair. It seems unfair that somebody that put a farm in some area of Colorado in 1880 to grow a crop they really shouldn't have been growing, having water rights to that, 100 years later, and being able to take all they want while the other people don't get any if they were latecomers.
What can you say about the drought in the Peonia Western Slope area? I heard that farmers are selling cattle because they can't, it's so dry over there and they can't afford the feed. But do you know anything about that?
Yes, very true. Forage costs money to grow and harvest, and you need sufficient water. And if you don't get enough rain, and even though you may have water rights, it can still be expensive.
When we lived in Tennessee, there was a mercury spill into that creek there from the uranium plants. Now, I know Rocky Ford here, they, after Rocky Flats, they cleaned it up. But did any of that sink into these aquifers? And having information in both of those industries, maybe you can tell me a little bit.
I know Rocky Flats had a couple of fires.
Can't hear you, Ron.
What?
I'm sorry?
Can't hear Ron.
Oh, okay. How about now? Am I closer?
Yes.
Yeah. I think this computer has a very acoustically sensitive sound thing, and I've noticed when Vicky's been speaking, often we can't hear her very well. So I'll try to close. Rocky Flats did release some small amounts of plutonium, but I haven't heard of any concern of that having promulgated deep into the aquifers at all. So that's I think it's been mostly surface soil issues there, which they've cleaned up pretty well. Yeah. But getting back to water rights, interestingly enough, the state of Texas was almost entirely sold off. Federal land in Texas is only about 3% of the entirety of Texas, compared to Colorado that has over 40% of federal land. That means the water rights in the state of Texas belong to private individuals and landowners, not the government. So a lot of people in Texas that own land are able to now have quite a reasonably good income source and potential for the future because of their water rights and the fact that it's private land where they draw the water and not public land. So much of our Denver water land is from Bureau of Land Management and federal property.
Ron, this has been very helpful, very informative. Thank you. Thank you. Certainly the political issues in the further development to the east of Denver, certainly in Arapahoe County going eastward, a great amount of building being projected and is currently taking place. I guess we're all concerned about the scrutiny and certainly the political issues of development versus water availability, and any additional insights on how political that issue is, and who's guarding the hen house right now when it comes to making sure we don't all go dry.
If you've got the moolah, you can buy water rights, and that's exactly what Aurora has done. Aurora has bought water from all over the place and dried up a lot of farms. Of course, on the other side of the coin, the very fact that agriculture is using 87% of the water, you can make a pretty strong argument. Should we be growing things like corn in Arizona, dry areas of Colorado, or should we be growing corn in Ohio and Indiana, where they don't need aquifers to grow corn? We've subsidized and we've artificially created an agricultural region in areas that flat out can't naturally sustain a lot of crops. So I can see both sides of it.
I can give you an example of where, can you hear me?
Yes.
Okay, I can give you an example in California of where things really backfired. This was before we moved here, so it's maybe 3-4 years ago. They announced that they were going to have water rationing. There was a drought, and they were going to limit the water that went to agriculture based on what crops you grew. Almond trees need a whole lot more water. But they said they were going to do this, but they announced it in the spring, said they were going to implement it in the summer, in August. So between the announcement and the implementation, there was this huge rush to plant almond trees. It just absolutely backwards, because those are the trees that need the most water. And if you had the almond trees in place by August, you got more water. So sometimes the government policies are not very far-sighted.
I know the state of Texas, water law varies dramatically from state to state. And I think the state of Texas has what they call the rule of the biggest pump. The person that puts the biggest, deepest well and puts in the most pumps, I think, can suck up all the water they want. Whereas in Colorado, there's some very strict prioritization rules in terms of who gets water and how much and when. How about water quality? Is everybody happy with their drinking water quality here in Colorado and at your locations?
Yes, I am.
And Susan, how about Canada? You doing okay in your province?
Yeah, well, Toronto's good anyway,
Okay,
but it's a huge issue nationwide because most of the people that are in the hinterland, which is comprised mostly of the indigenous population, don't have potable water. So it's a huge issue.
okay.
Oh,
Well, I don't know how many people in the class use water purifiers. We do. We purify our water. It tastes better. It just tastes better. I think there's something to be said about the additional purification. I don't know if others subscribe to that or not.
Of course, taste and quality don't always agree. Uh, Actually, if you've ever been in a chemistry lab and sample just a little bit of distilled water, it doesn't taste as good as good old tap water with some dissolved minerals in it. So you actually, for taste, want some dissolved minerals in it.
Whenever I travel, I'm always reluctant to drink out of the faucet. To take water out of the faucet at hotel room and drink it. I don't know, it's just me, I guess. I would just soon bring a gallon of water with me.
I also remember as a kid driving down through southern Georgia and Florida on vacation and stopping at some roadside parks and getting some water, drinkable water, but it had a noticeable sulfur taste that I didn't care for at all.
Ron, have any studies started on what the impact of climate change is going to have on our water supply?
Yes, they're thinking the Colorado River could see by 2050 maybe as much as a 30% decrease in volumetric flow. When they signed the Colorado River Pact way back in, I think, the 1920s, they assumed the wet years and the limited data they had was valid, and they badly overestimated how big the piece of pie was. And they divvied up certain amounts to different states, and the river simply has not and cannot deliver that water. And climate change is going to smack the southwestern United States, and already is, much, much harder. Lake Powell is at a record low level now. Blue Mesa Reservoir is going down 2 feet a week. The Colorado River is in real bad shape, and we're taking out more water in the region than we can handle. And climate change is not going to help the Southwest United States.
All the people moving into Colorado, that has to have a big impact on what is happening in the Denver area anyway. Is that correct?
Uh, we're hurting some, but the very fact that we're the source state,
Mhm.
we've got the snowpack, we're the source of all these rivers, and we have not taken our full allocation of Colorado River water and some of the other river water allocations. So we're going to feel it, but not nearly as much as the states downstream. We're fortunate to be on the headwaters. First dibs, first grabs.
Has there been any effort in Southern California to start desalination?
Yes.
Effort?
Yeah, they've got some reverse osmosis desalination plants there. It's a great technology. They're using it in Israel. Doing it some in Southern California. Bad news is it's expensive. It's virtually prohibitive to use for most agriculture, okay? It's very expensive water, but it's great drinking water. It's extremely clean, the reverse osmosis process.
Why is it so bad for agriculture? Is it
It's not bad. It's clean water. It's good water. It's just expensive. You have to
I see.
use pumping and filtration, pushing
Okay.
it through, and per gallon, the filtration costs are very, very high. Consumes a lot of electricity putting it through the filtration process. So it's very expensive water.
I've also read Saudi Arabia uses a desalinization almost like 90%. And you got to do something with all that salt. And it's absolutely, the discharge is absolutely ruining the Red Sea. So there's some negatives, even if you can get past the expense.
Yeah. Once you've filtered water and filtered out the bad stuff, you got to dump it somewhere. You can't just shoot it in outer space. All righty. Okay, well, Steve should be back next week. And hopefully everybody's had a pretty good summer here. We still got a lot to go. And we'll see what happens with our water situation. It's particularly for the Colorado River. It's looking really bad.
Thank you.
Thank you, Ron. This was great.
Thank you.
Everybody have a good week.
Thanks.
Bye.
Thank you, Ron. Very, very interesting.